Imagine a place where gravity is so strong nothing can escape. Not a planet, not a star, not even light. This isn't science fiction. This is a black hole. Think of space-time as a stretched sheet. A black hole punches a hole clean through. They are regions in space where gravity is all-powerful. An enormous mass squeezed into a tiny space warps space-time. It even bends light, creating cosmic mirages. Distant stars appear distorted, shifted, or ringed. Gas and dust spiral in, heating to millions of degrees. They glow incredibly at the edge, while the center stays black. Cross that edge, and the laws of physics as we know them break down. To grasp a black hole, you must let go of everyday intuition. In short, extreme mass, extreme curvature, extreme mystery. The most common black holes are born when massive stars die. For millions of years, fusion pushes outward, balancing gravity. When fuel runs out, the outward push weakens. Gravity wins. The core collapses in an instant. The outer layers explode as a supernova, seeding the cosmos with heavy elements. If the remaining core is heavy enough, it collapses past a neutron star to a singularity. A newborn black hole emerges, tiny, super-dense, warping space-time. From the ashes of a giant, a silent, powerful object is born. Every black hole is shrouded by a one-way boundary, the event horizon. Here, escape velocity exceeds the speed of light. Nothing that crosses can return. Imagine the river of space-time. The horizon is the waterfall edge. A distant friend sees you slow and redden, seeming to freeze at the edge. From your perspective, you cross smoothly. Your clock ticks normally. Inside, space and time swap roles. The center is the unavoidable direction. Tidal forces pull harder on parts closer to the center. First a tug, then stretching becomes extreme, a process called spaghettification. You stretch into a strand of atoms before being torn apart and drawn inward. At the singularity, our equations break. Density, curvature approach infinity. General relativity and quantum mechanics collide here, one of physics' biggest mysteries. What lies beyond is unknown. Sometimes two black holes find each other and spiral together. Their merger churns space-time, sending gravitational waves outward. In 2015, detectors heard the universe, a faint chirp from a distant collision. The final moments release immense energy, more than all stars combined in a blink. Black holes come in many sizes. At the heart of our galaxy is Sagittarius A, about 4 million suns in mass. We can't see it directly, but we see stars orbiting fast around it. They may grow by eating gas, swallowing stars, or merging with others, or forming early from direct collapse. We traveled to the edge of the abyss, stared into the maw of cosmic titans. They test physics, shape galaxies, and send ripples we can now detect. The universe is full of secrets. Want more space facts? Subscribe and keep looking up.